All right, eighth graders, in Unit 13, we're going to be looking at square roots. So what they are, how to find them. In Part 2, we'll look at simplifying square roots. Part 3, we'll look at rational numbers. So let's start with the definition. I don't really have a definition of a square root for you, more of an example. So if you think about the fact that 4 squared equals 16, 4 squared meaning 4 times 4. So 4 is the square root in this situation. So the square root is the number that you multiply by itself or square to get another number. So for the first section that says finding square roots, these are square roots that you should know, have in memory. These are just a couple examples. So the square root of 25 is 5. But now when we do a square root, by definition, it's you multiply it by itself to get something. So it's plus or minus 5. Because 5 times 5 is 25, and negative 5 times negative 5 is 25. So for 81, it'd be plus or minus 9. For 169, it'd be plus or minus 13. And for 225, it'd be plus or minus 15. So when it asks for the roots, plural, that means you do plus or minus. The next definition we have is of perfect squares. So it says the perfect square is a number that is the square of an integer. So remember, to square something means we multiply it by itself. So a perfect square is if we multiply an integer by itself. So for instance, 1 squared is 1. 2 squared is 4. Negative 3 squared is 9. 4 squared is 16. 10 squared is 100. And we can do a bunch of examples. But these numbers, so 1, 4, 9, 16, 100, are all perfect squares because you square an integer. Integer is a negative number, 0 or positive. Remember, no decimals or anything like that. So we can square a decimal or square a fraction, but it wouldn't be a perfect square. The next thing we're going to talk about is approximating a square root. It says approximate the square root of to the closest integer. So we're not going to use our calculator, but we're also not going to get an exact square root here. So we have the square root of 17. 17 is not a perfect square, but we want the perfect square that's closest to it just below it, and the perfect square that's closest to it just above it. So the closest perfect square below it is 16, and the closest perfect square above it is 25. So we say that the square root of 16 is less than the square root of 17, which is less than the square root of 25, which is all true statements. Then we're actually going to take the square roots of those. So I'll have 4 is less than the square root of 17, which is less than 5. I actually take the square root of 16 and 25. Then I need to think, okay, is 17 closer to 16 or 25? It's closer to 16, so I'm going to say that the square root of 17 is approximately 4. Next up, we have 250. So again, 250 is not a perfect square, so I want the perfect square that's just below it, which is 225. And I want the perfect square that's just above it, which is 256. I take the square root of 225, which is 15. I take the square root of 256, which is 16. I say that 250 is closer to 256, so it's approximately 16. All right, I'll let you guys try number 3. So our next definition is for a radical expression, and again, this is one of those math definitions that really just explains exactly what the problem already said. So a radical expression is an expression that includes a radical sign. Remember, expressions do not have equal signs. A radical sign is the square root sign, so that is a radical. So let's look at evaluating some radical expressions. It says evaluate the expression for a equals 4 and b equals 3. So for the first one, I have the square root, and then I need to plug in 4 for a and 3 for b. So 4 minus 3 is 1. The square root of 1 is 1. Now, your radical acts like a grouping symbol. So you do everything inside of the grouping symbol first. So for the second one, I have 5 on the outside. And then I have a, which is 4, times b squared. b is 3, so 3 squared. So I have 5 radical 4 times 9, because 3 squared is 9. So then I can do 4 times 9 and get 36. So now I take the square root of 36, which is 6, and then multiply those together and get 30. So the 36 is what's under the square root, so I get rid of that when I multiply to my final. Or number 3, again, remember these grouping symbols, or sorry, the radical sign is like the grouping symbol. I have to do everything inside of it before I actually take the square root. So I plug in 4 for A and 3 for B. So 4 times 4 is 16, plus 3 times 3 is 9. And then 16 plus 9 is 25. So now I can take the square root of 25, which is 5, and add that negative that's been out there, so I get negative 5 on my hand side. On the back side, we're looking at solving equations by using square roots. So remember, when we solve equations, we always do inverse operations. So like if we have addition, we do subtraction. If we have division, we do multiplication. If we have x squared, we have to square root it to get the answer. So I would start by boxing and rewriting. So I have x squared equals 36. Now I'm trying to get x by itself. That has not changed. Okay. Still trying to get x by itself, so I square root both sides. The square root of x squared is x. A square root and a square cancel each other out. The square root of 36 is 6, and I do plus or minus because either one would work. Let's look at number 2. I start by boxing and rewriting, so I have negative 8 y squared equals negative 32. Now again, my goal is to get y by itself. Okay. So the first thing I need to do is divide both sides by negative 8. And I'll wind up y squared equals 4. So notice I don't do the square root first. I have to wait till I just have y squared or whatever the variable is squared. Then I can take the square root. So the square root of y squared is y. The square root of 4 is 2. And put plus or minus 2. If either one will work. For the third one, again, I'm going to start by boxing and rewriting. 2x squared plus 32 equals 64. Okay, again, my square rooting is the last thing I do. So this is like a 2-step equation, but we're actually adding a third step. So I get 2x squared equals 32. Then I need to divide next. So that's x squared equals 16. Then I can take the square root of both sides. So I get x equals plus or minus 4. So notice the order that I went in. Okay? The first thing I did was subtract. So I'm going to add or subtract. Then I'm going to multiply or divide. In this case, I did division. And then the last thing I'm going to do is take the square root. So I've got to go in that order. Look at the next section. We've got a couple word prompts here. It says, you are helping build a sandbox for a community park. You want the sandbox to be in the shape of a square, so we're going to go ahead and underline that. We want it to be a square with an area of 30 square feet. You have boards with a total length of 24 feet to use as sides. Okay, and then we have a couple questions. It says, find the side length of the sandbox to the nearest tenth of a foot. So we know the area. So we know an area of a square is equal to side squared. Okay, so my area is 30, and that's going to equal s squared. I don't know my side length. So to solve that, I'm going to take the square root of both of these. So that gives me s equals 5.5 feet. And I just did that in my calculator. If you don't know how to do that in the calculator, I can show you. Okay, I rounded to the nearest tenth of a foot. Notice I only put positive because I can't have a negative distance when I do it. So I do the area. I put the square root of the area to get a side length. The next thing it says is find the perimeter of the sandbox. So for the perimeter of a square, that's just 4 times the side length. So in this case, I'm doing 4 times 5.5. When I multiply those together, I'll get 22 feet. So I have a perimeter of 22. Then the third question says, do you have enough boards to make the size of the sandbox? Okay, so if you look, we have a total of 24 feet of boards. We only need 22, so yes, we have enough. Scrolling down to the next part, the review problems. It says use the percent equation to answer the question. So quick review of this. Okay, for the first one, it says what percent of 24 is 42. So it says what percent, so that's x, of means multiplication, 240 is the equal sign 42. Okay, so that's 240x equals 42, and then I can divide by 240 on both sides. When I divide that, I get x equals 0.175. Now, remember, I'm looking for a percent here, so I move this to the right, I get 17.5%. So I want you to use that little reminder to help you. Okay, so x is going to be the what part. Whatever it says what for, that's going to be what you're looking for. Is the equal sign of means multiplication. Okay, so let's look at number 2. Number 2 says what number, so I'm going to put an x, is, we said it's the equal sign, 80% of its multiplication, 60. So I need to turn that percent into a decimal, and then I can just multiply. So x equals 48. So use those shortcuts to do the last two, and let me know if you have any questions.